Friends, welcome back to my channel. Today we will discuss how we can use TL494 in push-pull mode. How to take bipolar switching from this IC. Basically it is a second video on the same topic, as I received a comment from my viewer on my video number 449. In that video I demonstrated that how we can configure TL494 to take bipolar output to drive push-pull topology. First of all, we need to know what is the push-pull. In smps technology, when we say single-ended operation and single-ended or parallel operation, when we switch any component, when we have two drives and these are switching at the same time, when one is going high, second is going high. When one is low, the second is low. So these are working in the same way. It is called single-ended operation. This IC TL494, basically it is for bipolar switching, for push-pull operation. But when we use it in single-ended or parallel operation, it will work in this way. When we say push-pull, that means one will go high. This is one MOSFET, one transistor, one output. In that time, if this is low, the second will high. These will work opposite to each other. And I configured the circuit in that video. That was part 1 of that sequence, that series. It is push-pull. It have to drive two MOSFETs. We can use in half bridge the same, half bridge, full bridge, or we can use in push-pull. Because in half bridge we use two drives and we split the DC rail voltage by 2, 1/2 voltage. If we have 330 volt or 300 volt, we will divide into 2. 150 volt will be switched from one MOSFET and 150 from the other MOSFET. One MOSFET will work in this signal and second will work on this signal. While in full bridging we use full voltage, and in push-pull we use full voltage. Here we use 4 transistors, here we use 2 transistors, 2 MOSFETs, 2 switching devices. So we can say this configuration for IC is used to generate push-pull voltage. How we can control it? We control from pin number 13. If pin number 13 is controlled to pin number 14, it will work in this condition. And if we connect pin number 13 to ground, at that time this IC will work in single-ended operation. We will see the circuit layout. First of all, I will demonstrate how we can convert it. The message from my viewer Jobs Jamaica, he said, you said it is push-pull. It is wrong. Okay, we will see, is it wrong or is it correct? He said the both signals are pulsing at the same time. Okay, we will see it. Then he said, I damaged 20 MOSFETs. It is really very sorry. If you damage 20 MOSFETs, that means you damaged many things. He said pin 15 and 2 and I removed signal. Okay, let's check. First of all, I will configure pin number 13. This is pin number 13. Now it is connected to pin number 14. Now I am removing it. When I removed it from the reference voltage and I am connecting here, now it is working in the same time. We can check it now. The both signals are appearing at the same time. It is called single-ended operation. As in its data sheet, we can also consult the data sheet. If pin number 13 is connected to ground, at that time the both transistors will switch at the same time. If you can see, 9 and 10 are grounded and pin number 8 will drive this transistor and pin number 11 drive in parallel. it is called parallel operation or single-ended operation. If you connect pin number 13 to positive voltage, at that time it will drive in push-pull. Now if you can see, its frequency is 12.07 kilohertz. I am using 50 nanofarad capacitor, 1667 ohm resistance, so its frequency must be 11.997. So it's 11.997, that we can say 12 kilohertz. This is our calculated frequency, 1 over CT/RT, timing capacitor, timing resistor. And it is in that case when we connect pin number 13 to the ground. If we will connect pin number 13 to reference voltage, that is from pin number 14, now I connected pin number 13 to pin number 14. At that time the frequency will 1 over 2 CT/RT. This time 5998 hertz. It is in calculation, and if we see in practical, it is 6.02 kilohertz. So that's good. Now we can see the both signals are opposite to each other. If I overlay the signals, the yellow signal, that is channel 1, it is high, while the channel B signal is low. If yellow is low, channel B is high. Both signals are opposite to each other. If you are not connecting it properly, if you are not discharging the MOSFET gate, if you are connecting in push-pull and one MOSFET must be discharged at that time, you have to take care for the MOSFET discharging and charging resistor. If the gate capacitance is more, then you need to connect a gate discharging resistor, and you have to take care for the proper switching, because this circuit, it is used in inverter circuits. When we are using TL494 or KA7500, this topology is used because it is used for bipolar switching, for half bridge, full bridge, and it is also used for push-pull. When we are switching the maximum voltage into the smps transformer, this combination is used. This time the output frequency is divided by 2. If we check the frequency at the capacitor end, we can see this signal is now going high. When it is going high, it is switched. When it is going low, in this cycle it will remain off. One cycle will switch for high for one channel. In the same time, the second channel will remain off. It will cause to divide the output frequency by 2. Our RTCT is programmed at 12 kilohertz, and we are receiving output frequency 6 kilohertz. 6 kilohertz at one channel, 6 kilohertz at second channel. If we are using as a common emitter, at that time positive voltage to the collector, and we will connect emitter to ground, and we will receive output from collector. If we are connecting as a emitter follower, at that time positive voltage are provided to collector and we are receiving output. In both conditions we will receive the inverted output. It depends on the designer how he is designing the circuit. If you are configuring it in this way, that's okay. If you are configuring in this way, just only emitter follower configuration or common emitter configuration, you can use it. If you see the output control pin, the output control input determines whether the output transistors operate in parallel or push-pull. For parallel operation or single-ended operation, the output control pin must be grounded. If you connect pin number 13 to ground. At that time it will work in parallel operation, that is single-ended operation. Both transistors will switch together and we will receive full frequency. Now let's see. Here it is skipping one cycle, and if I will connect to ground, we can see it is switching at each cycle. When this cycle is coming here, it is high in the second cycle. So we are receiving the full frequency. That is in case when we ground pin number 13 of TL494. When we connect positive voltage, supply voltage to pin number 12, at that time this IC provides 5 volt reference. This time I connected error amplifiers as in the test circuit, pin number 2 and pin number 15, that are inverting inputs. I connected pin number 2 and pin number 15 through 50 kilo ohm resistor to the reference voltage, and I connected non-inverting inputs pin number 16 and 1 to the ground. So this IC is working at full duty cycle, and in this way we will receive a push-pull signal. So both signals are opposite. Now we can see more clearly. This is our one transistor, yellow one. It is high. It is giving switched voltage from the emitter. I am taking output from the emitter. You can take from the collector, you can take from the emitter. If you want to take from the collector, at that time you need to connect a pull-up resistor. Positive, and this is low. When second channel is high, the first channel will low. Both channels are opposite to each other. Why our friend damaged 20 MOSFETs? Is the biasing for the MOSFET is proper? Are you creating the dead time control perfectly? Did you calculated the gate charging and discharging resistor properly? Is the inductance for the transformer is perfect? And switching frequency, that is the biggest item in the switch design. Are you configuring the circuit with the same frequency which you want? If your circuit needs 100 kHz and you are switching at 50 kHz, at that time sure shot you must damage the MOSFETs. Frequency is directly involved in the switching. If you are not configuring the circuit properly, at that time the MOSFETs will damage. Otherwise, if you calculate the circuit properly, if you inject this signal to the MOSFET properly, then there is no reason that MOSFET will damage. Might be the material failure and might be the configuration error. If you configured something wrong, it will make problem. Similarly, if we have a feedback, when it will reach at its threshold, at that time it will adjust its duty cycle. And if we control the feedback properly, at that time it will adjust its duty cycle. This time I am just only controlling the compensation, because I connected non-inverting to ground and inverting input to positive voltage, so that it have to utilize the full duty cycle. Otherwise, if you are designing for a design, at that time you need to calculate, you need to adjust the feedback properly. And if you see now, the both signals are visible properly. Yes, now it is more clear. One cycle is on, the second green signal is low. When the green is high, the second is low. High, low, high, low. So it is push-pull configuration. If you see the circuit, that time control I connected to ground, so I am not providing anything for that time, so it will utilize the maximum dead time. And in the compensation I am connecting 50 kilo ohm potentiometer. It is just for demonstration. This end is grounded and this end is connected to reference voltage, and I am taking the taped voltage from this 50K potentiometer. It is just to give 0.7 volt offset to give a compensation voltage for the error amplifiers. I hope so this video is informative. If it is informative, hit the like button. If you have any question, let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.